Every time you interact with a machine, there is a delay between your initial thought and the machine's final action. This invisible barrier is cognitive friction. For decades, this translation required a manual process. You had a thought, you had to physically type them out, wait for a central processor to crunch the data, and then read the result off a static screen. We can think of hardware as a computer's biological senses, its indrion. Historically, machines operated in a sensory void. They were unable to see, hear, or feel the user until a physical switch was struck. Humans experience the world dynamically, taking in millions of data points through multiple senses at once. Machines, however, forced our intentions through a narrow, rigid bottleneck of clicks and keystrokes. Reaching the next stage of computing required a shift in hardware design. The focus moved from building faster calculators to creating sensory arrays capable of passive perception. Today, the keyboard is taking a back seat. Our bodies, voices, and environments serve as the direct input. Biometric sensors scan the physical ridges of a fingerprint in 0.1 seconds, removing the need to remember and type manual passwords. Ambient microphones monitor the room, capturing natural human speech and converting it into instant digital commands without requiring a single physical touch. Gyroscopic sensors, which measure orientation and rotation, allow hardware to read the exact physical gestures of your hand and map them directly to digital actions. These tools make giving commands nearly instantaneous, but accelerating the input only solves half the translation problem. If the machine's response is still trapped behind a flat, distant piece of glass, a bottleneck remains. The digital response had to break out of the desktop monitor and enter the physical space around us. Spatial displays utilize high-density screens and smart glasses to project digital visuals across your entire field of view, blending rendered graphics with the actual room you are standing in. Wearable technology ensures that you don't have to seek out a screen. Vital summaries and location data travel strapped to your wrist. We also incorporated haptic actuators. These small internal motors deliver precise physical vibrations, giving virtual interactions a tangible sense of weight and texture. However, as long as you use one dedicated device to send a command and look at a separate device to see the result, there is still a micro barrier between human intent and machine response. That final barrier falls when a single piece of hardware functions as the receiver and the transmitter at the exact same time. The smartphone touchscreen established this on-screen logic. The physical glass you press to issue a command instantly renders the visual reaction right under your fingertip. Virtual reality headsets push this loop further. They track your head movements and environment as an input, while simultaneously rendering an immersive 3D world to your eyes as the output. Haptic gloves close the physical gap. They capture the exact articulation of your hand, while internal mechanics push back against your fingers to simulate the feeling of solid objects. This chart visualizes the complete loop of modern tech fusion. Computing operates as a continuous cycle: human intent, signal capture, digital processing, and digital expression. The ultimate goal is zero latency, functioning as an invisible extension of the mind in one fluid motion.